We want the winner. We want whoever's on top to be inside the house. Okay, so the winner goes on top, which means that B, which is with the N, it's on the inside. The B goes on top because that's our winner, and the A goes underneath. Okay, so there is this is how we switch back and forth between the radical and the exponent. So in our example here, I have a 3 on the outside, but what do I have on the inside?
Nine.
I'm talking about inside, like where the X is in here. Yeah, there's a 1. There's an invisible 1. Remember that any number, if it doesn't have an exponent, technically the exponent is 1. So how do I rewrite this? Who goes on top? The 1 or the 3? Good. The 1 goes on top and the 3 goes underneath. That's x to the power of 1/3. So answer choice B. Okay, so that is how we kind of switch back and forth. So the cube root of 27x became 3x to the power of 1/3. We're going to do a couple more, but we're going to get used to that, being able to switch from one to the other. And this right here, if you want to take a picture of it, okay, or write it down in your notebook, that's going to be a good thing to just kind of, it's one of those things you just can memorize. You can sort of look over it over the weekend and memorize it. Here's another one. I want you guys to try this one now. See if you can figure this one out.
Do you want us to write it in chat?
You can write it in the chat or say it out loud.
Oh, we can do that right now?
Well, okay, I'll give everyone about 30 seconds.
Oh, okay.
Okay, now if anyone thinks they know the answer, what do we think?
I think I do.
What do you think it is?
I think it's C.
C, 3/4. Or sorry, 3 to the power of 4. How did you get that from this?
So I basically remembered that when there's no number on like the radical thingy, there's always an invisible 2. So if we do what you just taught us, which would be like, let's say, B over A, I think you put, it would be over 2, which is equal to 4.
Good. Perfect. Okay, that was the key thing. I didn't say it at first because I wanted to see if you remembered it. But when it's just the radical, that's the square root. That's like a normal square root. So that's why there's a 2 out in the front. And then, yes, you convert that to 8/2, and 8 divided by 2 is 4. So we get 3 to the power of 4. Do I have any questions on that one? All right. Okay, now we got a tough one. We've got a pretty tough one. We got to remember a couple of things before we begin. So before we begin, let's just go over, we already went over the radical rule, so I'll write that one down to begin with. Okay, that one we already know. Here's another one though. If you have a number to the power of a different number, parentheses to the power of yet another number. So this is called the power of a power, because it's kind of like inception, right? Like you've got a power and then you've got another power on top of that. That's just going to be n to the power of a times b. So you just multiply those two numbers. Okay. Oh, I know. I'm sorry that I'm cutting in and out. I apologize if that's the case, but let me know if there's something that you miss, like that if I miss like a whole thing. All right. So we're just multiplying. When you have the power of a power, we just multiply those two numbers. That's all we do. So over here, let's kind of rewrite this. I have 7x to the power of 3, and all of that is taken to the power of 2. So I'm going to kind of rewrite that. That's going to be 7 to the power of 2.
Wait, Ms. Lopez, I have a question.
Mm-hmm.
Oh, wait, I think you're going to do the example. But when it's AB, is it adding A and B or multiplying?
Multiplying, because a, b, if there's two variables like just written next to each other, they're being multiplied.
Okay, thank you.
Mm-hmm. So 7 to the power of 2 times x to the power of what? I've got a 3 and then a 2.
6.
6, because we multiply them. Times, now I have x to the power of, I have 8 and I have 1/2. So what do I get?
Wait, Miss, I have another question now.
Okay, what is it?
How did you get 7 to the power of 2?
Because that 7 had an invisible power of 1, right? But then it was in those parentheses, and what's on the outside of the parentheses?
2.
2. So 1 times 2?
Oh, okay, I understand.
Okay. Now this last one, it's x to the power of 8 to the power of 1/2. So what do I end up with?
4.
4. Good. How'd you get 4?
8 times 1/2 equals 4.
Mm-hmm. Exactly. All right. So now I've got this. So now I've got to simplify a little bit more. 7 to the power of 2
49.
is 49. And then this brings me to the last thing to go over. If I have a number, to the power of a times the same number, it has to be the same number, to the power of b. Oh, that was supposed to be purple. Hold on, I have to make this perfect. Me and my color coding. Okay, so this is different from the one above, okay? Because now I'm multiplying two different terms together. N to the power of a times n to the power of b. What ends up happening is I'm going to add a plus b. Okay, I'm adding now. So here, what do I get? X to the power of
10.
10.
Ms. Lopez, I have another question.
Go for it.
When it's x times x, it would normally be like x squared.
Mhm.
Why don't you like add the like 10 and the 2 because you have x squared? Like, do you understand my question? I don't know. I don't know how to explain
Which
it.
10 and which 2?
So, normally when you do x times x, it
Mhm.
would become x squared, right?
Mhm.
Since in this case we're multiplying x by x, oh, oops. Why don't we add a 2 to the already exponents?
Why don't we add a 2? Well, x times x is x to the power of 1 times x to the power of 1 equals x to the power of 2. So we're still adding those two numbers, right? 1 plus 1 is 2. It's the same thing is happening here. It's just that these have different exponents. This is x to the power of 6 and x to the power of 4. So I can't just give them a 2 because that's not what we're doing.
Okay, thank
Okay.
you.
Mm-hmm. Any other questions? Okay. Let's see what's up next. Okay, here's another crazy looking one. Looks insane, right? There's a lot going on. But in the answer choices, do I have radicals or do I have exponents?
Both?
In the answer choices, are there any radicals?
Never mind. No. Just exponents.
Just exponents, right? So what we can begin by doing is let's turn those radicals into exponents, okay? So here I have x squared y z to the power of 4. And if I want to turn that radical into an exponent, what would that exponent be?
1/3.
1/3, good, because I have
Oh,
this
okay.
3 on the outside, he's going underneath, so it's 1/3. Good. Let's do the same thing with the other one. This one is x squared y z to the power 4. And here we're going to do it to the power of. It's not 8. If the first one was 1/3, what would the second one be?
1/6.
Yeah, 1/6. Because I've got this 6. So all I did was I rewrote it. Instead of making it a radical, I rewrote it as an exponent. Well, now take a look. Inside of those parentheses, are things the same or different? How did I get 1/3 and 1/6? Who can explain?
I tried to explain it, but I don't think my explaining is good.
Try it though.
Which I don't think it's gonna come out good. Like I already tried to explain it to her, but
How did I turn this? Hold on. Let me rewrite it the way I had it before. How did the cube root of x, this right here, turn into this right there? Why did I rewrite it like that?
because technically the variable is like the variable to the power of 1 because it's just itself.
That x is technically going to the power of 1 because it's just itself. So the numerator is a 1 and the denominator is a 3, following this rule. I'm just following the rule. That's all I'm doing. The number on the outside of the radical goes in the denominator. The number on the inside of the denominator goes in the numerator. So here, same thing. I have 3 on the outside, so that goes underneath. And everything on the inside is technically going to the power of 1 because it's just times itself. There's nothing, they're not multiplying by anything else. So I can rewrite it as 1/3. And that goes for any radical. Like, I don't know, the 4th cube of x is x to the power of 1/4. The 12th root of y is y to the power of 1/12. That's just how the rule works, okay? So that's all we did first. Now, from this point, what is the same? It looks like on both of them, we have x squared y z 4. X squared y z 4, right? Not that both of those are the same. So what can I do to these two exponents? What should I do to them if I'm following the rule correctly?
Multiply them, add them.
Ooh, that's the question. Is it multiply them or add them?
I
Uh,
think multiply them.
Perla thinks multiply. Do you guys agree or disagree? Should I go back? Look at your rules that we have so far. Should I be adding those two or should I be multiplying those two?
I think multiply because it's like in parentheses.
Don't
like
let the
that.
parentheses fool you. What are we doing?
Oh,
What is that crucial thing that's happening in between those two terms?
oh,
We're multiplying two different things, right? So we're
yeah.
gonna add them. We're gonna add them.
I thought, Miss, is my fault because I thought you were talking about the parentheses itself, not like the whole little.
Oh, you
line.
were thinking, okay, you wanted to do 1/3 times 2 and 1/3 times 4?
Yeah, that's what I was thinking you were asking.
That would be correct, but that would actually end up being more work because then you'd have to multiply them on everything and then you end up doing twice as much work. But since what's inside the parentheses is exactly the same for both, we can just add the exponents. 1/3 plus 1/6, how do I do that?
Common denominator, which
Common
would be
denominator.
2/3. I mean 2/6.
2/6 plus 1/6
1/2.
is 1/2. How did you get 1/2? Well, this would be 3/6, which is exactly 1/2. So at the end, we end up with x squared y z to the power of 4 to the power of 1/2. Answer choice C. Questions on that? This is probably one of the more confusing standards, I would say, just because there's like exponents are definitely just annoying. Like I agree, they're annoying. But it's only 19% of the test. Chances are you'll probably get like one question about this, maybe two, like maybe if you're unlucky. So this is not the thing you should stress about. If you happen to remember it, great. If you don't, it's getting one question wrong is not going to ruin the whole test for you. We definitely learned this. Sorry, guys, if you don't remember it, but we did. All right. Which of the following are equal to p to the power of -3 to the power of 2/5? So this brings us to our last rule, I think. So ignore the problem so far. Quick recap. Actually, let me just copy them from here. So far, we have these three rules. Let me add one more. N to the power of -a, so any negative number, equals,
One of them is D.
okay, we'll see. I haven't even looked yet, Daniel, so we'll see. So if you have a negative exponent, what ends up happening is the following. Okay, your whole thing gets turned into a fraction. This one is probably the most confusing of them all, but let's see how this works. So here, first things first, I have parentheses and I have exponents. So should I be multiplying -3 times 2/5, or should I be adding -3 times 2/5?
Multiplying.
Multiplying. Which of these four rules does that correspond to with?
The second one.
The second one. That's this, the power of a power. So this would become, what's -3 times 2/5?
-3 times 2/5.
Mm-hmm.
-6/5.
-6/5. Agree so far?
Yes, I agree with Perla.
Mhm.
The smartest.
Does anyone else agree with Perla?
I don't agree with the last part she said though.
Which part? That she agrees with herself?
No, she's the smartest in the world.
I did not say that. I meant that she's a brilliant person.
Yeah.
So
I'm just
then it would
improving her
be
self-confidence
P.
enough. Today in society, people have low self-esteem.
Oh my god. I'm done.
Y'all are annoying.
Would we keep that as a fraction or would we simplify it into a whole number?
So that's the question. So basically, notice that it's saying select all that apply, right? So there's more than one correct answer. There's a lot of different ways this can go. We can do a couple of things to it. So one thing that we can do is we can look at rule number 4, right? Rule number 4 tells me that if I have a negative exponent, I have to turn that whole thing into a fraction. So this would become 1 over p to this power of 6 over 5. Because remember, once you turn it into a fraction, that exponent becomes positive. So now it's positive 6 over 5. Do we see one that's kind of like this somewhere in our answer choices?
C had the idea, but
B, maybe. Where else?
B, and
C.
Yeah, it looks like these middle 3.
Ms. Lopez, I
Actually,
have
the
a
middle 4.
question.
Yes.
So can't we technically, this is probably wrong, but can't we multiply by 1? No, never mind, because that's the numerator. Never mind. Or divide by 1 to get rid of it?
To
I
get
don't
rid
know.
of the...
The 1, the numerator.
No, because it's not an equation. We don't have an equation here. We
Oh.
have an expression. We're not solving for anything, so we can't just get rid of things. We can move
Okay.
things around and change them up, but we can't get rid of them.
Oh man, okay.
Okay, so all right, so there are a couple of options for us. Let's see. Which one do you guys want to see if might be right, or which one do you guys think might be right that we can check?
I think A might be right, but I know I'm probably wrong.
oh,
Daniel, what did you say? I didn't hear you. Was that Daniel?
yes, that was me.
What did you say?
D.
D. Okay. A, B, C, D. Okay, I see D. D looks interesting, right? Because it looks like we have, it looks like they did, instead of what we're doing, they took a different route. So they,
To what is it called?
here, let me move this over. It's kind of a game. We kind of just have to see if we can turn one into the other. But basically with D, how can I rewrite, what can I do to rewrite D? What operation should I use?
Multiply the 2 on -3.
Yeah, we can multiply 2 times -3, which is -6. And now let's rewrite
Divided by
this.
5.
Mm-hmm.
So,
So this would be p to the power of?
-6 over 5.
-6 over 5. Is that correct for us?
yes.
Yeah.
Yeah, we already know that that matches. These two match. So D is correct. Nice job, Daniel. You knew it from the start.
Oh, so is A. Yay.
Didn't do it in, I did it in a different way.
How'd you do it?
So I took the expression at the top
Mm-hmm.
and then I did it backwards.
So you went from that one. Okay, so what you did was you were like, okay, 2 over 5, that's the same as, let's see, we can do p to the -3. That would be this, right? 2 over 5 turns into that.
Yes.
And
Could
yeah,
reverse the exponents in here and it would still have the same outcome.
good. Nice job. So see, you can, that's what I'm trying to get at, that like this type of question, you can figure out the answers a bunch of different ways. So there's no one right way to do it. You just have to prove that they're going to be equal. Is there one that's definitely, or actually, is there another one right off the bat? Now we know that D is correct. I think Tyrone and somebody else said A is also correct. Do we agree?
Yes, I agree with myself.
Yeah, because this is the
I
same
also
thing.
agree with me.
Yeah, 5 and then -6. That gives us the same exact thing. So yes, that one's good too. So A is good,
Yay.
D is good. How about B? Does B look correct, or does it look like they did some faulty mathematics?
They did wrong
Correct.
math.
Wrong.
Some possible faulty mathematics happened here. Because yeah, I don't know,
Yes.
how would you get 15?
If they did 3 times 5 maybe.
Yeah,
What
3
Paula
times
said.
5, but
Yeah, but you would have to multiply the numerator, not the denominator.
exactly. So it looks like they did 3 times 5 instead of 3 times 2. So that doesn't look right. What about p to the power of 30? How do you get that?
Oh, they probably did 3 times 5 maybe. Or
3
they could
times
have
5
done
is
it
50.
both ways. They could have done it both ways. They could have done 3 times 2, which is 6 times 5, 30, or 3 times 5 times 2.
Right. So it looks like they did like instead of they just forgot how to multiply fractions, I think. So the 30 doesn't make any sense. E, I'm going to skip for a second because that one's interesting. We'll look at it together. But what about the last one, F?
No.
Definitely not.
No.
Yeah, definitely not. That
I
one
would
doesn't
have
make
a
any sense.
completely different outcome because of the thing in front of the thing.
Mm-hmm. Right, this would be p to the power of negative 1/10, but can you get to negative 1/10 from there? Nah, definitely not. Okay. However, this one that I'm looking at, E, there's something interesting about this one. How can I rewrite this? The square root of p. How do I rewrite that?
E times 1/2?
Mm-hmm. P to the power of
Oh,
1/2. And we're multiplying these, so what can I do to those two numbers? 5 and
add them.
1/2. We're going to add them. How do I add 5 plus 1/2?
5.5.
Oh, yeah. Tyrone said common denominator.
Mm-hmm.
So that would become 10 over 2,
Mm-hmm.
which would be 11 over 2, which would be, I don't know how to do math, 5.5.
5.5 or 11 over 2. Okay. 11 over 2. That doesn't look right, does it?
Yeah, but there's another p.
Hmm?
Yeah, but what about the other p? Oh wait, you already multiplied it.
Yeah. So since this is in the denominator, this would be p to the power of negative 11 over 2. But I don't see a way to get there, guys. Do you?
No.
Definitely not.
Yeah.
Wait.
This one's a
Yeah,
little
no.
bit wonky as well.
It would almost be 6.
It would almost, yeah, they almost got us, but
The thing is, it's negative and everything.
yeah, exactly. All right, so there we go. Those are our two answer choices, A and D. So this one was like a little bit tougher, but now we've got all 4 rules. So these 4 rules are what you should try to just memorize. I know it's not ideal, but sometimes memorization actually works. Okay, write them down, take a screenshot, and the more problems you do on the homework doesn't have this, unfortunately, but you can always work on it
No,
on
not
Saturday.
unfortunately. Fortunately, this is so much hard math.
I think this is no, there's 2 more. Okay, 2 more. Let's finish this out. I tried to do as many problems as possible for today. That way we get a lot of practice. So we've got 27 to the power of 1/3 over 9 to the power of 1/2. Okay.
We can turn the 1/2 into 3 over 6, and then we could divide that by 2.
But then that would just bring you right back to 1/2, wouldn't it?
We're trying to get rid of the fractions.
Yeah, because look, all those answer choices are whole numbers. So what is one thing we know that we can do to rewrite it a different way?
Take the, never mind. I was about to say take the square root. I kind of have an idea.
Okay.
Because
1.5
taking the square root would make it 27. So taking the square root of 27, which is 3. Wait,
Not the square root,
no,
but the
cube.
cube root.
No,
Yeah.
don't listen to me. Never mind.
You're on the right track though, because what's another way to write 27 to the power of 1/3? How can I rewrite that? We know a different way of writing the same thing.
27 to the, I don't know.
Go back
take
to
the
your,
square
which of these
cube
rules,
root.
Which rule does this apply to?
The first one?
The first one, we have a fraction in the exponent. So how can I rewrite 27 to the power of 1/3?
For that one, miss, wouldn't it be, wait,
Going back, I have a fraction. I can rewrite that as a
Decimal?
what is that called? Follow the rule. If I have a fraction in the exponent, I can rewrite that as a, what's this?
oh, radical.
Radical. So how do I rewrite that?
3 on the radical and then 27 inside.
The cube root of 27. What about 9 to the power of 1/2?
That would just be 9 to take the square root of 9.
The square root
Today.
of 9. So I have the cube root of 27 over the square root of 9. What's the cube root of 27?
Do like the cube root for both of them?
The cube root of 27 and the square root of 9. So what's the cube root of 27?
Booga booga.
We did this like 4 slides ago. What's the square or the cube root of 27?
3 and 3.
3, and the square root of 9 is also 3. So 3 over 3?
1.
1. That's how this problem works. So when again, we have to be comfortable with those rules going back and forth, because one way might be easier to understand it than the other way. It's much easier to understand this than that. Okay, this is the last one. Last one. I have parentheses. What should I do between those parentheses?
Wait, miss, are we gonna do the same thing we did on the last? Oh, no, because they don't have the same numbers, right? And exponents.
Right, so we can't just
Oh.
add.
Okay.
But I know a rule that I can use when I have exponents on the outside of parentheses. What can I do?
Multiply.
Just multiply.
Good, so we're distributing it to both.
Oh.
Both. So 4 to the power of 1/2 times x to the power of 3 times 1/2 is,
Oh, yeah, 1.5.
but we're going to keep things as fractions. We don't use
3
decimals.
over 2.
3 over 2. 9 to the power of 1/2 and x to the power of 1/2. Now, what do you think? Can I rewrite this an easier way for myself?
Yeah, I think you could do it with the x's, right? Because they have the same variable.
Yeah, so why don't we kind of move things around? 4 to the power of 1/2, 9 to the power of 1/2, x to the power of 3/2, x to the power of 1/2. What are some things I can do now?
The exponents.
Which exponents can I add?
3/2 and 1/2.
Good, just these. Can I add these two together?
No.
No, because they have to have the same base.
Why?
We'll talk about these in a second because there's something else we can do with those. But for now, let's add 3/2 plus 1/2 is
1/2.
1/2.
No, 2. Wait.
3/2 plus
Yeah.
1/2. is 4 halves,
2, yeah.
which is 2, sorry. So x squared. And then how can I rewrite 4 to the power of 1/2 to make it easier for myself to understand?
2.
How'd you get 2?
I divided 4 by half.
So we're not really dividing though. What are we doing?
Multiply. And that gives 2. So 2.
Multiplying.
What about 9 to the power of 1/2? What's that?
4.5.
No, because we're not dividing it by 1/2. What are we actually doing? Guys, we just did this. We just did this.
Multiply. Add.
Oh,
What did we just do?
it's like taking the square root.
Power of 1/2 is the same thing as square root. So this is the square root of 4 times the square root of 9 times x squared. So what's the square root of 4?
2.
So you were right that that's 2, but then this is 3.
So A.
So A. Guys, force yourself to remember this. Anything to the power of 1/2 is the same as just the square root of that number. Force yourself to remember that because this is the last problem we're doing of that.
Good.
Good. Any other questions? Okay. All right. Next thing, NRN 2.3. Rational versus irrational numbers. Can I have a volunteer read what are rational versus irrational numbers?
Fraction.
Go ahead and read it.
Can be written as a fraction.
Okay, but read what I wrote.
Rational. Can be written as a fraction.
And what about irrational?
Irrational. Endless decimal with no with no pattern, which cannot be written as a fraction.
Good.
Wouldn't that be like pi or something?
That's imaginary numbers. You'll learn about that in Algebra 2.
There's a second algebra.
Yeah, that's what you guys are going to take next year.
No! Isn't geometry enough?
No.
Geometry is enough.
And then after that, you got to take calculus. Ooh, you got a long life ahead of you. Trust me.
Isn't geometry supposed to be more advanced than like algebra?
Yeah, but then Algebra 2 is even more advanced than that.
Miss, can we quit?
No quitting. All right, so guys, this is easy. Rational numbers can be written as a fraction. Irrational numbers are endless decimals with no pattern. So tell me, which of these numbers is rational? Give me one.
0.3.
0.3. What's that little bar? What's this bar on top of the 3? Tell me.
Isn't that like a fraction bar?
Wait, does
Not a
it
fraction bar.
keep going on and on and on and on and on?
Yeah, so when you plug that into your calculator, what does it actually look like?
I don't know.
The calculator won't give you a bar. Yeah, 0.33333333333 forever.
Okay, so never mind.
So yes, that's what that means. So tell me, is that rational or irrational?
Irrational, because
Why?
it's endless.
Keep reading. Endless decimal with
There's
No pattern.
all the leaves.
Okay, but does that have a pattern? Yes or no?
Yes.
Oh, yes. So
that's rational.
Oh, okay.
Okay, what else? Give me another one. Doesn't matter if it's rational or irrational.
Pi.
Pi, what's that going to be?
Irrational.
Irrational. It doesn't have a pattern.
Good. Okay. What's another one?
0.128128 is irrational.
0.
Good. That one is rational because there is a pattern. 0.
0,
What's that going to be?
Rational.
Good. Keep it going.
12, rational.
That's not just a 12, that's the square root of 12.
Still, it's rational.
I think that's
Because
irrational.
that would be like 4.
Would it? Plug it into your calculator. What's the square root of 12?
4 times 4 is 16.
Oh,
So what would 12 square root of 12 be?
uh, never mind, it's irrational.
0.21.
Theory, what is the square root of 12?
It's irrational. It's 3.4641011615.
Irrational.
Okay. What about the square root of 16?
Rational.
Rational.
Good. What about negative 5?
Rational.
Rational. What about the square root of 2?
Irrational.
Rational.
Irrational.
Irrational. Questions on what is rational and versus irrational?
No, this is
For
way
the most
easier
part,
than
no.
what you guys were doing.
Yeah, not too bad.
Or
Okay.
For real.
Take a screenshot, take a picture of this screen.
I don't need to.
Yes, you do. Do it.
Do not.
We're going to memorize this. It's not hard to memorize because it's the same pattern. But when you add or multiply rational and irrational numbers, here's the pattern. It's the same. A rational times a rational is always rational. Rational plus a rational, always rational. So that first box is always
What about
rational.
dividing?
Dividing is the opposite, so it goes hand in hand. So this is really addition and subtraction. This is really multiplication and division. Okay? Goes hand in hand. But again,
Oh yeah.
Okay.
Multiplication is just. Dividing is just multiplication backwards.
yeah, they go hand in hand. But anyways, rational times rational, always rational. Irrational times irrational is sometimes rational. So sometimes it is, sometimes it's not. It kind of depends. But rational, when you mix them together, so a rational times an irrational or rational plus irrational, it's never going to be rational. Okay, and the pattern is the same for addition as well as multiplication. So it's not too hard to memorize. It's just something that we got to get stuck in our brains. Okay, so go ahead and take a screenshot, take a picture, and let me know if I can move on. Can I move on?
Yeah.
Yeah?
No.
No?
I'm just.
Yes. Yes.
All right, so now let's answer some questions about it. Use the properties of rational and irrational numbers to answer each question. Which of the statements is true? Let's just go true or false. Ready? The sum of two irrational numbers is always irrational. True or false?
True. Wait.
The sum of two irrational numbers.
That is a lie.
That is a lie. It's going to be sometimes. Sometimes it's rational, sometimes it's irrational. It goes either way.
Because sometimes there could be like something like too irrational, and then you could equal a whole number.
Okay, B, the product of two irrational numbers is sometimes rational.
True.
Yeah, that is true.
True.
And let's just check the other two. The product of a rational number and
False.
an irrational. No, that's not sometimes, that's never.
False.
And finally,
And
the
false.
sum of two rational numbers.
False.
What is this? Would it be sometimes irrational?
Never.
It would never be
If
irrational.
they're both rational, then they're just gonna stay as whole numbers.
Yeah. All right. So there we go. And now part B, which of the statements using operation on rational or irrational numbers always results in a rational number? Which of the following?
D.
Said D?
Rationals always result in a rational.
Good.
We just went over it.
We just went over it. So again, this is, I bet you, I promise you, you will get at least one question like this, and it all goes
And
back
it'll
to
be
just
super
memorizing.
easy. It'll be super easy. I don't need that. It's easy.
Okay, I'm glad it's easy for you, Daniel. It's because you're good at memorization, but those who need to
No,
process
I'm
things
not.
a little slower, okay, I'm just warning you that you will see a question like this, and it all goes back to memorizing that little chart.
I'm not good at memorizing.
Okay, now let's look at some actual values. Which of these will be irrational? So let's take a look.
Okay.
So
Going back before, let me quickly come to this again. Which
Okay.
option always ends up irrational? Which option always
rational and irrational.
good when you mix them together? So irrational with irrational would never be rational. And that goes for multiplication as well as addition. Okay, so now let's look at our options. Do we see one where we're either adding or multiplying rational and irrational?
B?
I think it's C.
Which of these answer choices mixes things up?
B.
C.
B?
No, C doesn't mix them up.
For B, is the square root of 2 rational or irrational?
Irrational.
This is irrational.
8 is irrational.
And
2
8
irrational.
is
So
also
that's 2
irrational.
irrational.
Hold on. Yeah, so these are 2 irrationals, which is
C
sometimes. Sometimes it's irrational, sometimes it's rational. So we don't know.
C is the same case, but it's being divided by 5, so that may change the whole thing.
Okay. What about D?
D, one of them is a fraction, so we know that's
It's a
is
irrational.
a 3, so it's
Yeah, so it's irrational minus irrational. So again, that could go either way. What about A?
That's 4 is irrational, right?
Mm-hmm.
yeah,
Irrational.
And when you mix them up, what happens?
always rational,
Always what?
irrational, yeah.
Always irrational. So even
That
though
means the answer is C.
C, why?
Because those other ones are irrational with irrational.
Yeah, but we're looking for one that gives us an irrational answer.
Oh, then it's A.
Then it's A. And let me also prove it to you, because let's look at all the other answer choices.
We already answered it.
Pause. I know, hold on. Pause, Daniel. The square root of 2 times the square root of 8 is the same thing as the square root of 2 times 8. What's 2 times 8?
16.
16. What's the square root of 16?
16.
What's the square root of 16?
4.
16.
4. Daniel, only say the answer if it's right. 4. So is that rational or irrational? Is 4 a rational number or an... Okay.
We
Good.
literally
rational.
saw that in A, that 4 is rational.
Good. Okay, what about this one? Square root of 3 times the square root of 12
That would be 36 over 5.
Rational. Wait.
is 12 times 3 is 36. What's the square root of 36?
Random number, I don't know.
You should know this. What's the square root of 36?
Wait.
Thank you, Emily. 6. So this is 6 over 5. Is that rational or irrational? It's a fraction, which means it's rational. Let's do this last one. This is the square root of 3 minus 3 to the power of 1/2. Well, can I rewrite one of those a different way?
Yes. Minus square root of 3. So it's square root of 3 minus square root of 3.
How can I rewrite the square root of 3?
You get the half, and you and it goes like this, and you put the 2 over it, but if the first one is basically the same thing as the other one because it's automatically squared.
Okay, so those are two of the same thing. So when you take the same thing from itself, what do you end up with?
0.
0, and we already know
Rational.
that's rational.
Rational.
Okay, so A is the only one that gives me an irrational number, and that's because I'm taking a rational. So 4 is rational. Rational plus irrational will always be irrational.
Rational.
Okay, I think we've got one more.
Mhm.
Read and think to yourself first for 30 seconds. Don't yell anything out. Is the product of the square root of 2 and the square root of 8 rational or irrational? Okay, guys. 30 seconds has passed. What do we think? Is it going to be
Irrational because we did it before, and also because both of those are irrational, and it's only rational sometimes if you combine them, but both of them are irrational. So off the chair I go.
okay? So Daniel says irrational. We have one vote for irrational. Does anyone agree or disagree?
I was gonna say rational, but I'm probably wrong
Well, what's your explanation, Perla?
because I just saw you like, oh, never mind. I just saw you do 2 times 8, right?
Sometimes.
16, and then the square root of 16 is 4. So that's a rational number, but I'm not sure.
Good.
I need to
You're
pause
correct.
it.
So that's where you have to be very careful. So here we're talking about the product, right? So we're doing the square root of 2 times the square root of 8. And remember what I said, when you're multiplying, you can bring them all together inside of the radical. So this is 2 times 8. 2 times 8 is 16, and the square root of 16 is 4.
Yeah, I said irrational.
Oh, you said rational. It's hard to
I
tell
said
sometimes.
yeah, they sound the same.
They do.
No,
Okay,
you
so
didn't.
this
You said
is,
irrational, miss.
yeah, I know.
Ha ha ha.
This is rational. Now, what if I said the sum of square root of 2 and square root of 8?
Some
Rational.
Mm-hmm.
wouldn't it be the same thing?
Oh, it could be sometimes rational or irrational, right?
That would be sometimes. So it goes either way, and you kind of have to know each time. In this case, can those come in together in the radical?
Let's see.
So since we're adding, I cannot do this. Cannot do it. That's just not a rule.
There is a pattern that will
So,
technically.
so therefore, this would be irrational. There's no way to get a nice number out of that. So this question was to show you that it could go either way. When you have two irrational numbers, it could go either way, and you kind of have to test it out each time just to check. Questions on rational versus irrational?
Well, technically, after the 3.16, there's the numbers repeat themselves 2 times. 227766. If that pattern goes on, then.
If it has a pattern, then you're good. Janelle's on the other one, it was adding, yeah. Here, it was adding, yes. And for that reason, it's irrational. Okay. All right, we're moving on to the last thing, which is now we're going to do statistics. So SID. statistics is a lot of different things in one, but one of the things that comes up a lot is calculating the median, the mean, the range, all of those things. And we got to kind of remember what all of that means. So
So
pause, because I'm going to explain first, okay? Give me a chance first, and then I'll let you guys speak. First of all, one thing that's not here in this problem, but we still need to know how to do, is the mean. Can anybody remind me how to calculate the mean?
I'm pretty sure it was the range minus the median or something like that. Oh,
What?
I'll give you a clue. Mean isn't also known as average.
isn't that like the median?
Subtract all the no. Wait.
To find the mean, so you have to add every single value and then divide it by the number of values.
Oh, yeah.
Good. Add them up, then divide by the number of items. So here I have candy bars, right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of those numbers. So we're going to add everything up and then divide by 15. That's how you find the mean. So you would go 0 plus 35 plus 38 plus 41 all through, okay? Now I'm not going to do that right now because yeah, it takes a long time.
Wouldn't it technically be
But
14?
but that's how you do it. So that one's pretty easy. Mean is pretty easy. Median. Does anyone remember what the median is?
I know.
Go ahead.
The median is like the middle number, so you would have to like put everything in order from least to greatest, every number, and then you would find the middle number. Usually, if it's an odd number, you would find like the middle number, but it's an even number of numbers. Sometimes you have to add the two middle numbers and then divide it by 2 to get your median.
Perfect, exactly. So here, are they already kind of in order from least to greatest?
They're already in order.
They do look like they're in order. So I'm going to go from one end and cross off to the other end, cross it off. And we're just going to keep crossing off until I get to the middle.
It's not C or D. I can't see the whole A.
There it is. That's my middle number, 53. So the median is 53, which looks like that's answer choice C, but let's just finish it off. Range. How do I find the range?
Wait, why did you choose answer choice C, miss?
Because I already got it right.
It says which one is false.
Oh,
not which
you're
one
right.
is
Thank
right.
you.
Ms. Lopez, you're about to get the question right.
B or A.
Whew.
A doesn't make sense.
And then we're gonna fail the EOC.
No, we're not, Tyrone. You have to be optimistic.
Okay, how do I find or calculate the range?
Don't you subtract the biggest number by the smallest number?
Yep. Biggest minus smallest. So here that would be 120 minus 0, which is 120. Okay.
What's the outlier? I forgot.
What's an outlier?
Outlier.
Outlier.
It looks like outlier, so I'm gonna say outlier. Doesn't look like liar.
Oh, I don't know about that.
Okay, an outlier sounds kind of like what it sounds like, okay? It stands out.
Miss, isn't that the one that's like all the way at the end by itself?
Yeah, it's any number that basically stands out.
So
So most of your numbers are in the 60s, and then you have one number that's 15. That 15 would be an outlier.
okay. So
Does anything stand out here?
the answer is A.
The 0 and the 120.
Yeah, that 0 and that 120. Everything else is kind of like in the 30s, 40s, 50s, 60s, like in that range.
A.
And then one is much smaller and the other one is much bigger. So it might be that might be the answer. However, let's look at the first answer too. The mode
the answer is A.
best. The mode is the best measure of central tendency. What is mode?
Don't know. Don't
I
care.
don't know that we already got it.
Don't you like have to actually? Is it something to do with subtracting? Wait.
It's the most common value.
Number?
So are
Oh.
there any values that repeat
68.
68,
68
53.
and 53? But which one is the most common?
68.
69.
68. That's my mode. My mode is 68. Is that going to be the best measure of central tendency? No, because central tendency is like,
no.
where is the middle?
Either.
Is this telling me where the middle is of all those numbers?
No, no, no. So it's A. I said it was A.
Okay.
I was
So-
right.
Okay, thank you, Daniel, but you're interrupting me and I'm not sure if everyone else understands, because if you're the only one speaking, then I can't really help everybody else. Okay. So that's the question, is the mode the best measure of central tendency? What if the number that was repeating the most was 0? Would that be in the middle?
No. Wait. Yeah.
That would be in the middle of all the
No, it
numbers?
wouldn't be in the middle. It would be at the start.
Yeah, it'd be at
That
the
would be at the
start.
start. Why would it be in the middle?
So what I'm trying to get at
Zero
is
like
that,
the lowest number.
okay, Daniel, I'm gonna mute you. Thank you.
Okay.
The mode is never really going to be the best measure of center, because the mode, we don't know where it might be. Sometimes it's in the middle, sometimes it's in the beginning, sometimes it's at the end, sometimes it's in a completely random place. So the mode is just, that's never going to be the best measure, because we never know where it's going to be. So that one is not it. Okay. Do you guys know what would be the best measure of center? Which value kind of tells you where the middle is?
The median.
The median is always pretty good. And do you know what the other one is that's pretty good at telling you what's in the middle?
The mean?
Yeah, the mean. We didn't calculate it in this case, but if you did, you would probably get something in the middle as well. If anyone wants to do a 0 plus 35 and calculate it, you can do it and tell me what you get. Okay, here's another one. Which statement is true if a 10th data point of 45, so if I add another one, is added? Okay, it looks like we need to know about the mean and the median. So before we add 45, what would be the median versus after?
9.
The 9 is the median?
The median was 9. Yes.
Are they written in order though? Be careful.
No.
No, right? They're
Well,
not written from least to greatest. So let's start out by writing them from least to greatest. We've got 8. No, 3.
come on.
Oh, I skipped the 3, 5,
7,
7, 8,
9, 9, 10,
9, 9, 10,
10, 11, 12, 45. Actually.
11, 12. And we're not going to add the 45 quite yet. So before we add the 45, the median would be?
9.
Oh, you were right. It is 9. What about the mean?
And
Let's add them up. Take a calculator out. 3 plus 5 plus 8. Oh, plus 7 plus 8 plus 9 plus 9 plus 10 plus 11 plus 12.
no, I don't need a calculator. It's over 9,000.
I got 74.
74.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 9.
8.22222.
Good, 8.2.
So the answer is C.
We don't know yet, because now we're going to add 45.
Yes, we do them. We do know.
We're going to add that 45 now. What's my new, do I have the same mean or a different mean? Let's find out. 1, 2.
Different mean.
And what about median?
Median is still 9 because there's 2 9s in the middle, they wouldn't change.
Yeah, it's still 9.
The
So
mean
we're still,
will the mean will increase and the median will remain the same. So C. C, 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 C,
C
C.
sounds good to me. And we can check by adding 45 to what we got
Yeah.
before. And you do end up, what do you get with, what's our new mean? Did anyone get it yet?
102 or something like that. Cause
Miss, did you freeze or are you
you
not?
said it was
Never
cause
mind,
you
you didn't freeze.
cause you
Yeah,
said
it
it
would
was like
be
7.
it would be 11.9. Yeah. So yes, the mean increases and the median stays the same. Questions on this one?
No.
We just kind of
No,
had,
just a long process.
yeah, just doing all that math, you know. All right. Dot plots, easy, 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 guys.
Also,
Dot
Miss
plots are,
Lopez.
yes.
Nevis's phone died.
Okay, can she hear me from your screen, maybe?
Let's see. What's the lowest number?
Miss, I have a
16. All of them have
question.
16.
Okay, what is your question?
How do I read stem and leaf plots? I don't get those.
Those are not on the EOC. Don't worry about them.
Okay, great.
Okay, but dot plots are. So let's make sure we know how to read these. So you basically just have to match up all the right numbers. Okay, we got 16 on all of them. Then we should check if there's a 19, which there is. So which answer choice is out?
B.
B is out. Now I'm gonna see how many 20s are there. I see
2.
one.
So that means they're all correct for now.
Yeah, for now we're still good.
24, 23. The
Let's
answer is D.
check if
Oh,
there's a 20. Is there a
D or C.
22?
D or C.
Is there a 22?
No, it's D or C.
Wait.
Yeah, there's no
D or
22.
C.
Daniel, please. I heard you the first time. Thank you. There is no 22, therefore A is out. What can we check between D and C?
29.
Yeah, let's see if there's a 29. Is there one?
It's C. It's C. Daniel, you're wrong.
Yeah, there is. So it's C. Okay. Dot plots are easy. Not much to
There's a lot of these questions.
Hey, not my fault. I didn't skip like the whole plot.
Okay. Here, they might make you create one, so might as well just practice that really quickly. But again, this is easy. We just fill it in as you go. 65, 65. Basic stuff, right? Do I have any questions on this?
No.
No, it's easy.
Okay, good. Now, I'm just drawing it out because I want to show you one thing.
Okay, yeah, that's easy.
Yeah.
That is my part.
Okay. Questions on making a dot plot?
No.
Easy stuff.
No.
Now, does this have normal distribution? Who remembers what that is?
What did you say, Miss?
When they're
Normal.
like equal on both sides. Like
Yeah, normal distribution will look like a little hill, like a bell curve. Do we have normal distribution here?
No.
And
It's
then
so
abnormal and then abnormal
There's no such thing as abnormal distribution, but
Um,
basically you just say it does not have normal distribution. Before we answer this question, does this one have normal distribution?
almost.
Does it make a hill?
It looks like a hill, but
Yeah.
it's not like perfect.
I would say this is definitely normal. It doesn't have to be perfect in order to be normal. It just has to at least have like some semblance of a hill. So yes, this one's normal. How many of Vanessa's classmates eat more than 5 servings each week? More than 5 servings.
7.
So remember, to read this, you kind of have to see where it lies. So the first bar
6 to
is
7.
on the 2. Second bar is on what? How many people fit into that second bar, that orange one?
5.
5. What about the green one?
9.
9.
4.
4.
3.
And 3. So
That
how
means
many
7.
people greater than eat more than 5? That's going to be these 2 bars. 7 people. Questions on that? Still,
Easy.
this is why I put so many of these on, because they're pretty easy.
Yes.
There's a lot of these.
Okay. A landscaper records the heights, blah, 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 blah. Complete the histogram. So it's not completed by selecting frequencies for the heights of the newly planted trees in the community garden. Okay.
This
So
is all yours.
pausing here. So here I need to know how many of them are between 0 and 1. Do I have any that are between 0 and 1?
No.
No, right? Hold on, let me see by selecting frequencies for the heights of the newly planted trees in the community garden. Oh, okay, I see what it did. Okay, this one's a little bit weird. I'm gonna skip this one. It's not a good question. But basically, if this list had like 2.1, 2.2, 2.2, 2.3, where would those all go? Where would those all of those numbers end up? Between 0 and 1, 1 and 2, or 2 and 3? Anyone? All of those numbers, 2.1, 2.2, 2.2, 2.3 are all between what numbers? 2 and 3, exactly. And there's 4 of them, so I would make a bar up to the number 4 and fill it in. Okay, that's my bar graph, histogram. Okay, and then finally, we don't have enough time, so I think we'll do this tomorrow, but the last type of graph you have to know about is box and whisker plots, and we'll talk about that one tomorrow.
I remember that. I love
Yeah, those are fun. They're fun, but we'll do them tomorrow. As a reminder, Saturday and Sunday from 1 to 3 p.m. I better see you there. I'm going to post a link on Teams on Saturday, but you have to be there for at least a half an hour on one of those days. Come with questions. I can go over homework problems or any class problems that we maybe skipped through or did too fast. All right. That is all for today, guys. Have a good day.
And I'm gonna go to those office hours and I'm gonna stay from 1 to 3 for
Good.
both days.
Good. I'll see you there.
Good. I'm trying to pass this EOC.
You will. Bye, everybody. Send me your addresses. If you didn't yet, send me your address on Remind, please, please, please. Samaj, Alejandro, Jalen. Bye.